Okay, now we'll go to part 2, chapter 1, real numbers. Now we'll continue from part 1. I had left this question, the ratio of LCM and HCF of the least composite number and the least prime number. So what is a prime number? Prime number, it has one factor and the number itself. So 2, 3, 5, 7, 11, 13 are prime numbers. Composite numbers, we have more than two factors. That is 4, which is not a prime number, will be a composite number. So 4, 6, 8, 9, 10, 12 are composite numbers. Now what they are asking in the question, what is the ratio of LCM and HCM of the least composite number and least prime number? So what is the least prime composite number? Least composite number is 4. Okay, least composite number is 4. And least prime number? Least prime number is 2. Okay. Now what they are asking, ratio of LCM and HCF. So LCM of 4, 2 by HCF of 4 and 2. 4 is the least composite number and 2 is the least prime number. So this they are given in the question. Okay. We have to find out. We have to find out this. The ratio of LCM of least composite number and least prime number. HCF of least composite number and least prime number. This we have to find out. So how you will find out? 4 you will do by prime factorization. 2 2s are 4, 2 1s are 2. So for 4 you can write as 2 into 2 into 1 equal to 2 squared. And for 2 you can write as 2 1s are 2. So 2 into 1 equal to 2 to the power of 1. So LCM of 4, 2 will be, you have to write all the individual numbers. So what all individual numbers given? 2 is given, 1 is given. So what is the highest power between these two? Between 2 and 1, what is the highest power? 2. So 4 is the answer. 4 is the LCM of 4, 2. And for HCF, common. What is common here? 2. 1, 2 is common and 1 is common. So 2 into 1 is equal to 2. So we found out the ratio of LCM by HCF. So 4 by 2 is equal to 2 2s are 4, 2 1s are 2. So the ratio will be 2 is to 1. 2 is to 1 is the answer. So B is the right answer. 2 is to 1. Okay. Read the question and you can find out the answer easily. Good morning children. Now we are going to see part 2. So I am going to the next topic. So already we have learned the definition of HCF. What is HCF? The largest number which can be divided by all the numbers, leaving the remainder 0. So R is equal to 0. So for example, 5 divided by 25. So 5 5s are 25. So it completely divides. So here the remainder is equal to 0. So 5 5s are 25. So it completely divides. So its remainder is equal to 0. So we can take the HCF. Supposing if R is not equal to 0, then what you will do? Supposing example 6 divided by 37. So 37, 6 6 are 36. So here the remainder is equal to 1. So we cannot completely divide 37. 6 cannot completely divide by 37. So what number can we minus 37 so that we can completely divide 6? So 37 minus 1 will be 36. So we can say 6 divided by 36. So here R will be equal to 0. So the remainder will be equal to 0 when we completely divide. So we will see some examples in the next. Now the next question is, find the greatest number which divides 281 and 1249, leaving the remainder 5 and 7 respectively. Okay. They are saying some number, greatest number. But what is HCF? HCF means dividing all the numbers, leaving the remainder 0. But here they are saying leaving the remainder 5 and 7 respectively. So some number, okay, we don't know which number. So that two numbers, 281 and 1249, okay, it leaves the remainder 5. And for this it leaves the remainder 7 respectively, means For 281 it leaves 5, and for 1249 it leaves a remainder 7. But when we want to find out the HCF, the remainder should be equal to 0. This is only the rule, okay, if you want to find out the HCF. So what can we do to get the HCF? So when we minus 281 minus 5, you will get 276. So we got the first number. And 1249, when we minus 7, we got 1242. So we got the second number. Now we can find out the HCF of 276, 1242. Okay. Now we can find out the HCF of 276 and 1242. So what is the prime factorization? 276. 2 ones are 2, 2 threes are 6, remainder 1, 2 eights are 16. 2 6s are 12, remainder 1, 2 9s are 18. 3 2s are 6, 3 3s are 9. So 23 is a prime number, so it's divided by itself, so 23 into 1. Then 1242, what's the prime factorization? 2 6s are 12, 2 2s are 4, 2 1s are 2. Then again 3 2s are 6, then here it will come 0 because 2 we cannot divide, so next number you have to go 1. So 3 7s are 21. Again 3 6s are 18, remainder 2, 27, so 3 9s are 27. So here 3 2s are 6, 3 3s are 9. Again 23 is a prime number, so it's a. So what are the prime factorization of 276? 2 into 2 into 3 into 23. And then for 1242, 2 into 3 into 3 into 3 into 23. So here we can write as 2 into 3 cube into 23. Now what is the rule of HCF? What's the rule of HCF? Only take the common. So what all commons are there? 2 is common, then 1 3 is common, and then 123 is common, that's all. Okay, so HCF of 279, 1242 is equal to 2 into 3 into 23. Only what are the common? HCF, what is the rule? Only take out the common. That is the rule of HCF. Only take out the common. So 2 into 3, 6 into 23. So 23 into 6, 6 2 is 18, 6 2 is 12, 138. So 138 is the right answer. You understood? So what is the question? The greatest number which divides 281 and 1249, leaving the remainder 5 and 7 respectively. So what is the definition of HCF? HCF when it divides, it should leave any number when it divides, it leaves the remainder 0. But here we don't know, it leaves the remainder 5 and leaves the remainder 7 respectively. So to find out HCF, what we'll do to make the remainder 0, we are minusing 281 minus 5 and 1249 minus 7. Okay, so we are getting HCF of two numbers. After getting the HCF of two numbers, what's the rule of HCF? HCF, the rule is take out common. So here 2 is common, and here 3 is common, and here 23 is common. So we found out the HCF is equal to 138. So 138 is the right answer. Okay. Okay, the next question is find the smallest number which when increased by 17 is exactly divisible by both 520 and 468. So forget this when increased by 17. So what is LCM? The smallest number is exactly divisible by both 520 and 468. Forget this increase by 17. So the smallest number 520, two smallest number 520 and 468, when the remainder is equal to 0, we can find out what is LCM. Okay. The smallest number we can find out when the remainder is equal to 0, 520 and 468. So first we will find out what is the LCM of 520 and 468. Okay, because already in the question they are given the smallest number that is exactly divisible by both 520 and 468. So we know we have to find out the LCM. So we will forget that increase by 17, leave that part increase by 17. First let us find out what is LCM. So for LCM, how you will do? 520 for prime factorization. 2 2s are 4, remainder 1, 2 6 are 12, 2 1s are 2, 2 3s are 6, then 2 6 are 12, remainder 1, 2 5s are 10, then 5 1s are 5, remainder 1, 5 3s are 15, then 13 is a prime number. So for 520, what is the prime factorization? 2 into 2 into 2 into 5 into 13. So is equal to 2 cube into 5 into 13. And for 468, what is the prime factorization? For 468, 2 2s are 4, 2 3s are 6, 2 4s are 8, 2 1s are 2, then again 2 1s are 2, remainder 1, 2 7s are 14, 3 3s are 9, remainder 2, 3 9s are 21, 3 1s are 3, 3 3s are 9, then 13 1s are 13. So for 468, it is 2 into 2 into 3 into 3 into 13. This you can write as 2 squared into 3 squared into 13. Okay. Now what is LCM? LCM, first you have to write what all individual numbers are available. So 2 is available, 3 is available, 5 is available and 13 is available. First write all the numbers. In LCM, first you have to write all the numbers. Okay. What all different numbers are available in this category? Different species. So what all numbers are available? 2 is available, 5 is available, 3 is available, 13 is available. Okay. Now which is the highest power? Which is the highest power? Which is the highest power? In 2, when you compare 2, 3 and 2 is the, in this which is the highest power? 3 is the highest power, so write 3. In 5 only 1 is there, 1. And in 3, 2, only 2 is there. So write 2. And 13, 1 is there. Okay. So this is the answer for LCM. So LCM will be around 4680 when we multiply. We will get 4680. Now what is the question? Find the smallest number which when increased by 17 is exactly divisible by both 520 and 468. First you found out what is LCM. Now what is given in the question? In the question they are asking find the smallest number, which we don't know what is that smallest number, which when increased by 17 is equal to LCM, that is 4680. Understood? What's the question? The smallest number when increased by 17. We don't know which is that smallest number. When increased by 17 is exactly divisible by both 520 and 468. So we found out the LCM is 4680. So when we increase by 17, you will get 4680. So what is that smallest number? So we are asking what is the smallest number. So x plus 17 is equal to 4680. So x will be equal to 4680 minus 17. So x will be equal to 4663. So 4663 is the answer. Nothing. What is the question they have asked? Find the smallest number which when increased by 17 is exactly divisible by both 520 and 468. So what is the smallest number? We know they say smallest number itself, we know we have to find out the LCM. So when we find the LCM, the remainder will be 0. If it's exactly divisible, the remainder will be 0. So we found out the LCM. After finding out the LCM, what we have said, the smallest number, find the smallest number when increased by 17 is equal to, already we found out what is LCM. So your LCM will be 4680. So according to the question, we have written this equation. The smallest number which when increased by 17 is equal to 4680. So we will see the smallest number as x. So x plus 17 is equal to 4680. So x is equal to 4680 minus 17. So x is equal to 4663. So this is the answer. Okay, the next question is find the smallest number which when divided by 12, 16 and 24 leaves remainder 7 in each case. So this leaves remainder 7, we will come back later. First we know what question they are asking. The smallest number which when divided. So you know what is LCM. LCM is whichever number, smallest number which is divisible by all the numbers. So they ask, first we will find out what is LCM. According to the question, first we will find out the LCM. So LCM of 12, 16 and 24. Here the remainder will be equal to 0. When we get the LCM of 12, 16 and 24, the remainder will be equal to 0. Okay. LCM of 12, 16, 24, the remainder will be equal to 0. So first we will find out what is LCM of this. So 12, 2 6 are 12, 2 3s are 6, 3 1s. So for 12 the prime factorization method 2 into 2 into 3 into 1. So for 16, 2 8s are 16, 2 4s are 8, 2 2s are 4, 2 1s are 2. So for 16 it is 2 to the power of 4. And for 24 is equal to, for 24, 2 1s are 2, 2 2s are 4, 2 6 are 12, 2 3s are 6, 3 1s are 3. Okay, for this it is 2 cubed into 3 to the power of 1. So you know what is LCM. LCM of 12, 16, 24. How you will find out the LCM? First take what all individual numbers are there. Here only 2 is available and 3. What all different terms are there, different numbers. What different species are available. Okay, so 2 is there and 3 is there. And comparing on all the 3, which is the highest power. So this is equal to 2 squared into 3. So comparing all the 3, which is the highest power, 4 is the highest power. So we will write for 2 to the power of 4. And for comparing 3, only 1 is there, so 1. So this is the answer is 48. So we found out what is LCM. LCM is 48. Now in question what they are asking, the smallest number which when divided by 12, 16 and 24 leaves remainder 7. So leaves remainder 7 means 48 plus 7. So 55 is the answer. Okay. Can we check how 55, how the remainder 7 is coming? So when we do by 55, 12 4s are 48. So here it leaves the remainder 7. Okay. So this leaves the remainder 7. So the answer is 55. According to the question, so this is the smallest number which leaves the remainder 7. So 7 is the remainder. Here, for every number to try and see, it will come 7 has remainder. So for 16 also, 55, 16 2s are 32, 16 3s are 48. So 48, so again leaves the remainder 7. So for every number, the remainder will be 7. Okay. Okay, find the next question, find the LCM and HCF of two prime numbers, x and y are prime numbers. Okay, now let us take an example 5 and 7. Here 5 and 7 are two prime numbers. Let us find out what is the LCM and HCF of 5 and 7. So 5 when you take prime factorization, it will be 1 and the number itself. For 7 also it will be 1 and the number itself. So when we do 5 is equal to 5 into 1. And then 7 will be equal to 7 into 1. So for LCM, what is this LCM of 5, 7 will be all the individual numbers. What are numbers available? 5 is available, 7 is available and 1 is available and the highest power. So the highest power will be 1 only. So the answer is 35. So LCM of 5, 7 is 35. And then HCF. So HCF for 5, 7 will be common. So here what is the common? The common is 1. So can we write HCF of 5, 7 has 1? Okay. Just see what observation we are getting. So in the second example, can we take as 2, 3? For 2 also, what is the prime factorization? 2 1s are 2. And for 3, it will be 3 1s are 3. So when we take for 2, we will write 2 into 1. And for 3, we will write 3 into 1. And when we take LCM of 2, 3, what is the observation can you see? 2 and 3 are the individual numbers. So we will write 2 and 3. For HCF of 2, 3, what is the common? So 1 is common, so you will write 1. So what is the observation between these two examples? What observation can you see? So LCM when we take 5, 7, it is the product of two numbers. And HCF when we take, it is always 1. So can we write LCM of x, y is equal to product of two prime numbers. So xy. where x and y are prime numbers, and HCF of x comma y is equal to always 1. So this is the answer. So this will be product of the prime numbers and this will be always 1. Only where x and y are prime numbers, then only this formula will be suitable. Only if x comma y are prime numbers. So for any prime number x and y, HCF will always be 1 and LCM will be product of the two prime numbers. Okay, understood? Okay, the next question is the LCM of two prime numbers p and q, where p is greater than q is 221. Find the value of 3p minus q. Okay, now what they are given in the question, LCM of p comma q is equal to 221, where p is greater than q. The condition they have given, p is greater than q. So can we find out the prime factorization of 221? So 221 will go in which number? So it will go with 17. With 13 it will go. So 13 ones are 13, then 13 sevens are, then 17 into 1. Okay, 13 sevens are 91, so 17 ones are 17 itself is the prime number. So we found out the two factors p and q. Now they are saying p is greater than q. So if p is greater than q, then p will be equal to 17 and q will be equal to 13. Okay, understood? If p is equal to 17 and q is equal to 13. So we found out what is 3p minus q. So we have to find out the value of 3p minus q. This is the question, 3p minus q. So how you will find out? So 3 into 17 minus 13. So 3 into 17, 51 minus 13 is equal to 38. So 38 is the answer. Okay, 38 is the answer. So what they are telling us, the LCM of two prime numbers p and q. So we know the LCM of two prime numbers p and q is equal to 221. So we know LCM of p and q will be equal to product of two prime numbers. So product will be p and q. So that's why we took the prime factorization and 13 into 17. So 13 into 17 is 221. So we got the product of two prime numbers. So from this we analyze that p is equal to 17 and q is equal to 13 given p is greater than q. So they are asking the value of 3p minus q. So from 3p minus q, what is p we found out and what is q we found out, then the answer is 38. So very easy question, only we know the concept. The LCM of two prime numbers will be product of the prime number and HCF will be 1. So using that we found out the answer. Okay, now the next is relation between HCF and LCM. So what is the relation between HCF and LCM? For any two positive integers p and q, you know what are the positive integers, 1, 2, 3 till infinity. So what is the relation? LCM of p comma q into HCF of p comma q is equal to product of two integers, product of two positive integers. So LCM of p comma q into HCF of p comma q is equal to product of two positive integers. Okay, this is the relation, positive integers. So LCM of p comma q into HCF of p comma q is equal to product of two positive integers. So this formula you should know. Okay, what is this formula? LCM of two positive LCM into HCF is equal to p into q. Okay, the next question is the LCM and HCF of two numbers are 180 and 6 respectively. So LCM they are given as 180, HCF they are given as 6. And then if one of the number is 30, find the other number. So one of the number they told 30, find the other number. Okay, now we know already what is the relation between HCF and LCM. HCF into LCM, HCF into LCM is equal to product of two numbers. Okay, this is the formula we already know. So using this formula we can find out HCF is 6 and LCM is 180 and one of the number is 30 and you are finding out what is Q. So 6 into 180 by 30 is equal to Q. So 0, 0 cancel, 3 ones are 3, 3 twos are 6, so 18 into 2 is equal to Q. So 18 into 2 is 8 twos are 16 to 36. So Q is equal to 36 is the answer. The question what they have given LCM, HCF, they are given the one number, they have given 30, they are asking to find out the other number Q. So using this formula, HCF into LCM is equal to PQ. So 6 into 180 is equal to 30 into Q. So we want to find out the number of Q because that is another number. So 6 into 180 divided by 30, so Q is equal to 36. So 36 is the right answer. Okay. Okay, the next question is the HCF of two numbers is 16. So what they have given in the question, HCF they have given has 16. And the product of two numbers they are given as P and Q is equal to product of two numbers they are given as 3072, and they are asking find the LCM. So what is the LCM they are asking to find out? So we know what is the formula. HCF into LCM is equal to product of two numbers. Okay. So what is HCF here? 16. And what is LCM? We have to find out. And the product of two numbers they are given 3072. Okay. Now LCM is equal to 3072 by 16. So by 2 table we can do 2 8s are 16. 2 1s are 2, 2 5s are 10. Then 2 3s are 6 and remainder 1, 2 6s are 12. It will go again by 2 table. 2 4s are 8. Here 2 7s are 14, remainder 1, 2 6s are 12 and then remainder 1, 2 8s are 16. Okay, then again 4 table only it will go. So 4 1s are 4, remainder 3. So 4 9s are 36. Okay, and again 4 2s are 8. So LCM is answer is equal to 192. Okay, by using this formula, HCF into LCM is equal to product of two numbers. We got the LCM as 192. Now what is LCM here? Here LCM is equal to 192 and HCF is equal to 16. Okay. Now can we say that these are the two things. Now can we say that HCF is a factor of LCM. Factor of LCM, and LCM is a multiple of HCF. Okay, now HCF is a factor of LCM, so we know what is HCF. 16. So 16 will divide by 192. So we can say that prove that HCF is a factor of LCM and LCM is a multiple of HCF. By using these two examples, we can prove this, that HCF is a factor of LCM and LCM is a multiple of HCF. Okay. Now the next question is explain whether the number 3 into 5 into 13 into 46 plus 23 is a prime number or a composite number. Okay. What is a given question? 3 into 5 into 13 into 46 plus 23 is a prime number or a composite number. So now we cannot take anything common. Can we split this as 23 into 2? 23 2s are 46. So we can write this as 3 into 5 into 13 into 23 into 2 plus 23. Now what is the goal? Goal is we have to make it as product of prime. Then only we can say it is a composite number. So now we will make it as a product of prime. What is common here? 23. So when we take out 23, 3 into 5 into 13 into 2 and 23 will be into 1 because we have taken out 23 plus 1. So when we multiply this, it will come as 391. Okay. Now we can find out by prime factorization 391. So 391 how it will go? So it will go by 23. 23 ones are 23. So remainder 16. So 161. So 23 7s are 161. 17 ones are 17. It's itself a prime number. So we are splitting this as 23 into 23 into 17. So we know that this is a product of prime. So hence it is a composite number. This is a product of prime numbers. Hence the above question is a composite number. Hence the above number is a composite number. Okay. Just we have to prove that it's a composite number. Now we have to make the question into product of primes. So we are splitting this and making into product of primes. So while checking, then we can say the above number is a composite number. If the LCM of two numbers is 3600, then which of the following cannot be HCF? They have given the four options which cannot be HCF. So we know that if HCF is a factor of LCM, so it should be completely divided. So 3600 they are given as LCM. Okay. This should be completely divided into 600, 500, 400, 150. Then that will be the proper HCF. Now what is the answer? 3600 divided by 600, 0, 6, 6 are 36. So answer is 6. So remainder is equal to 0. So this is a factor. So 600 is a factor of 3600. So A is the right answer. So check for 500. 3600 divided by 500, 0, 5 36, 5 5s are 25, 5 6 5 7s are 35. So here the remainder is 1. So this is not a factor of HCF. It cannot be a factor of 3600. So A is the right answer. Okay. We should know that HCF is a factor of LCM and LCM is a multiple of HCF. So this is an important question. Now the next question is find whether the number 3 into 5 into 7 plus 7 is a composite number. So what is a composite number? Composite number, we know the definition. It has more than two factors and then it is a product of prime. According to fundamental theorem of arithmetic, composite numbers equal to product of prime. So we have to prove this number 3 into 5 into 7 plus 7 is a composite number or not. We have to prove it. So now how you will prove it? First we have to make it as a product of prime. So this term we should make it as product of prime. Then you can prove it's a composite number. Okay. So how you will try to prove it? So in this, what is the common? 7 is common. So inside it is 3 into 5 into 1. 3 into 5 into 1 plus 1. Okay. So 7 into 5 3s are 15. So 15 into 1 is 15. 15 plus 1 is 16. So 7 into 16. So 16 can we write by prime factorization. 2 8s are 16. 2 4s are 8. 2 2s are 4. 2 1s. So we can write this as 7 into 2 into 2 into 2 into 2. So all this is product of primes. All are prime numbers. All these are prime numbers, right? So we can say that this is a composite number because it is a product of prime. Okay. Because 2 into 2 into 2 into 2. So all are product of prime. So this number is a composite number. We can prove it. Okay. Okay, now the next question is, can two numbers have 16 as their HCF and 380 as their LCM? So what we are saying in the given question, HCF is equal to 16 and LCM is equal to 16 has LCM and 380 has LCM. So 380 has LCM. Now they are asking whether HCF can be 16 and LCM can be 380. If it cannot be, what is the reason? We already know that HCF is a factor of LCM and LCM is a multiple of HCF. So very important, learn this. HCF is a factor of LCM and LCM is a multiple of HCF. So if HCF is a factor of LCM, can we see it should be completely divided and remainder should be equal to 0. So let us check. 16 1s are 16, 16 2s are 32, remainder 16, then 16 3s are 48. So here remainder will be 12. So remainder is equal to 12. So this is not complete, it's not a factor of LCM. So these two numbers cannot be HCF and LCM. So give the reason. Therefore HCF is equal to 16 and LCM is equal to 380, they cannot be. Because they are not the factors. Okay. Because of this, HCF is factor of LCM, then LCM is a multiple. In these two above examples, we already saw in the previous thing, this LCM and HCF, they both are already the factors. So when we check the factors, remainder is equal to 12. If it is a factor, remainder should be always equal to 0. Then only it is called as a factor. Since the factor remainder is not equal to 0, so HCF and LCM, HCF equal to 16 and LCM is equal, they cannot be. Okay, this is the answer.